Hello students, today for class 10 I am going to start a new video, Arithmetic Progression, a series with sequence. It is the 5th chapter of class 10. Now first let us know what is arithmetic progression. First I am writing one sequence. First I have written 2, then 4, then 6, then if I ask anybody what will be the next number, everybody can give the answer. It will be 8, next it will be 10, next it will be 12, then it will be 14. How it is? By adding 2 to the previous term, we will get the next term. There is 2 plus 2, 4, 4 plus 2, 6, 6 plus 2, 8, 8 plus 2, 10, 10 plus 2, 12, 12 plus 2, 14, like that. This is called AP. Similarly, suppose we have written another series, another sequence, 50, then 45, then 40, then 35, then 30, like that. Then what it will be? Then what it will be? Then next term, then next term, then next term, like this. Here we see that every term is obtained by subtracting 5 or adding minus 5 to the previous term. There is 50 minus 5, 45, 45 minus 5, 40, 40 minus 5, 35, 35 minus 5, 30, like that. So these is called that this is the sequence in AP, arithmetic progression. So in case of arithmetic progression, the terms are obtained, the successive terms are obtained either adding or subtracting a constant number to the previous number. The constant term, the constant number which we are adding or subtracting, it is called the common difference. First term, it is denoted by A or A1, and the difference, the constant difference 2, 2, 2, 2 in this example, this is called common difference and is denoted by small d. It is in increasing order or in ascending order. So if the first term is A1, the second term will be A1 plus d, third term will be A1 plus 2d, fourth term will be A1 plus 3d, like this. So whenever we are getting the second term, we are adding d to the first term, so A plus d. Second term, A plus d. Third term, A plus 2d. So whenever the term is third, we are adding 2d. There is 3 minus 1. For the fourth term, 3d means 4 minus 1 into d. So in general, we can say that if we are finding the nth term, it is generally denoted by a suffix n or tn, capital T suffix n, or it is the last term L. So an or tn or L is equal to an is equal to a plus n minus 1 into d. For example, suppose the first term is true, the first term is 2 and the common difference is d. You want to get 1, 2, 3, 4, 5, 6, 7, there is 7th term. What is the 7th term? 14. How can I get it? So a7 an is equal to a plus first term plus n minus 1 7 minus 1 into d, that is a7 is equal to a plus 6d. So 2 plus 6 into 2, that is 2 plus 12, that is 14, and we see that actually the term is 14. Now for the AP, if we are getting the next term or successive terms by subtracting a common number, then it is called the decreasing or descending series, and the constant number that we are subtracting, it is called the common difference. So if the first term is a or a1 and the common difference is d, then difference of any term from its previous term, that is, if we are taking second term a2, then its difference from the first term a1. So a2 minus a1 is equal to d. It is called the common difference. We can also write a3 minus a2. We can also write a4 minus a3. We can also write a5 minus a4. There is difference of any two successive terms. N is equal to number of terms. Then an or tn is equal to nth term, that is L term. We can also write this as the last term L. So an is equal to, we already have written an is equal to a plus n minus 1 into d. Now let us find out what will be the expression for number of terms and d. Then from this we can derive n is equal to an minus a by d. Now what we have, nth term an is equal to a plus n minus 1 into d. From this we can derive that n, number of terms n, is equal to an minus a by d plus 1. So if you keep this expression in mind, you can save your time for finding the number of terms. Similarly, what is the expression for common difference? There is an minus a. Bring this term to the side. So an minus a divided by n minus 1. So divided by n minus 1. So d is equal to an minus a by n minus 1. Now suppose if we are taking the series from the back. Now whenever we are taking the series from the back, then from the back nth term, that is, if we are taking from the back, the last term will be the first term. Okay, and ascending series will be descending and descending series will become ascending. So from the back nth term an is equal to L minus n minus 1 into d. Recall the previous one, forward. An is equal to a plus n minus 1 into d. But in case of a, we are writing, since it is from the back, the last term becomes the first term. There is L minus n minus 1 into d. Okay. Now, for example, suppose I have written, there is 2, then I have written 2, then I have written 4, then I have written 6, then I have written 8, then I have written 10, then 12, then 14. Suppose this is the series. And from the back you want to calculate 1, 2, 3, 4. That is, this fourth term you want to calculate from back. Okay, then from the back, what is the first term? L. L becomes the first term. That is, last term becomes the first term. and this is the nth term, that is a fourth term from the back is the nth term. So if the formula is an is equal to L minus n minus 1 into d, then according to this formula the fourth term a4 will be L means 14, minus how many terms? Fourth term, a4, fourth term. So 4 minus 1 into d. What is d? 2, 4. So 4 minus 2, d is 2. So L minus n minus 1 into d. 14 minus 3 into 2, 6. 14 minus 6 is 8. So it is verified that this number will be 8. Okay. Now I am going to discuss sum of n terms of an AP. If we want to find the sum of n terms, let an AP, it is a, first term is a, then if the common difference is d, next term we will get by adding d, next term will be a plus 2d, next will be a plus 3d, like this. The last term is an, which is equal to a plus n minus 1 into d. So this is. Now let last term be first term a and common difference d, and the last term is an. Then the sum of first n terms, it is denoted by Sn, S for sum of n terms. Sum of n terms Sn is equal to n by 2 first term plus last term, or Sn is equal to n by 2, then n by 2 it is a, and in place of an is actually a plus n minus 1 into d. So what do you get? N by 2, then a plus an means a plus n minus 1 into d. So what will we get? A 2a plus n minus 1 into d. So for the sum of first n terms, I get two formulae. One, Sn is equal to n by 2 bracket a plus an, or a plus l, first term plus last term, or Sn is equal to n by 2 bracket 2a plus n minus 1 into d. Now here we have to know, to be noted this part, an, that is nth term, can be obtained. Suppose this is the nth term. So what is the term before this? That is, if I am writing a series, that is a plus d, a plus 2d, a plus 3d, an, which is equal to a plus n minus 1 into d. Now my question is, if this is an, what is the term before this? It is a n minus 1. It will be 1 less than this, because if this is fourth term, this is third, 4 minus 1. If this is third, then this is second, 3 minus 1, like this. Now if I want to get nth term, an, what we have to do? Find the sum up to an and then subtract the sum up to an minus 1. We will get this term. It is a common sense. So an is equal to sum of n terms Sn minus sum of n minus 1 terms, that is s of n minus 1, and S1 means sum of first term. Sum of first term, that is sum of single term. The term itself and its sum will be the same. That is S1 is equal to actually A1, that is equal to A, that is the first term. Because a single term cannot have its, that is sum. So sum is the term itself. Then A2, what we have to do? Let us find the sum up to second term and subtract first term from the sum. We will get the second term. So A2 is equal to S2 minus S1. It will get second term. Similarly, third term S3 minus S2. That is, we will get third term, and so on. That is, now to explain this one, I am taking one example. Let Sn is equal to 3n square plus n. Determine AP. That is, if the sum of n terms is equal to 3n square plus n given by this expression or defined by this expression, we need to find the AP. There is at least 3 terms to be determined. So first term. First let us write An is equal to what? Sn minus Sn minus 1. So what is Sn? 3n square plus n. 3n square plus n minus Sn minus 1. That is, n is replaced by n minus 1. Similarly, 3 n minus 1 whole square plus n means n minus 1. Simplifying this, we will get An is equal to 6n minus 2. Therefore, A1 first term, 6 into 1 minus 2, that is 4. Second term, 6 into 2 minus 2, that is 10. Third term, 6 into 3 minus 2, that is 16, and so on. Thus, can also be done in another ways. What we are given, I am showing you by another method. There is, as I have explained earlier, Sn is equal to 3n square plus n. For n is equal to 1, S1 is equal to 3 into 1 square plus 1. 1 square means 1, 3 into 1, 3 plus 1, 4. So 4. So what we get? Sum of first term is 4. What does it mean? Sum of first term means the term itself. So the term is 4. So the first term is 4. That is, this is A. Now for n is equal to 2. S2 is equal to 3 into 2 square plus 2. 2 square means 4. 4 into 3, 12. 12 plus 2, 14. It is the sum of two terms. If from the sum of two terms, if we are subtracting one term, that is the first term, what will remain there? Obviously the second term. Therefore, A2 is equal to S2 minus S1. As I have given you the formula, there is 14 minus 4, that is equal to 10. So this is the second term. Similarly, S3 is equal to 3 into 3 square plus 3. That is, 3 square means 9. 9 into 3, 27. 27 plus 3, 30. Now A3 is equal to S3 minus S2, that is equal to 30 minus 14, that is equal to 16, that is equal to A3. So what we get? First term 4, second term 10, third term 16, and so on. So this is the AP.